What is up, everybody? Yes, I know you are excited about it right now. We are going to do another geometry lesson on the video. Today, talking about section 4.7 in your textbooks, isosceles and equilateral triangles. We've talked a lot about them over the course of the year in this last chapter, so just a theorem or two to talk about to get you going here, and then a whole bunch of time to practice some problems. So, one theorem for you to copy down into your notes, and this will be on your reason page, so make sure you get it there as well. The isosceles triangle theorem. The isosceles triangle theorem says that if you have two sides of a triangle and they are congruent, then the opposite angles will also be congruent. Well, duh, we knew that. Alright, that's why it's an isosceles triangle. But this is just saving you the step in a proof to have to say it's an isosceles triangle and then say that the other pair of things is congruent. Alright, so all it says is if you got two congruent sides, then of course you got two congruent angles, and vice versa also works as well. So here we go, a little picture of it. Suppose you got a proof and you're working along and you know that this side is congruent to this side. Then we always know that if we go right straight across from those congruent sides, there indeed is the congruent angles, are the congruent angles. Gotta work on my English skills here. And like I just mentioned, it also works the opposite way. So if you know that those two angles right there are congruent, then across from those two angles will be your congruent sides. So let's see if we can figure out some problems on this. I'm going to put some practice problems up on the board right now. I'd like you to work with a partner on these problems. When the video says to freeze or pause it, then make sure you stop the video so that you can watch the problems and work on those. And then when you are ready, then you can go see the solutions. So if you would right now, pause the video. Alright, hopefully you had a chance to work on these. So now what we're going to do is look at the answers for them. Here are all the answers to those problems. The answers are circled down there at the very bottom. That's supposed to be 129 degrees. That got cut off. Again, you can freeze this right now so you can look at these answers. Alright, so hey, now we've got the second part of this, which is proofs. Yeah, you have to be able to do algebra problems and solve for angles and sides and things like that, but you also have to be able to do a proof. So I'm going to go over one proof with you right now, give you a little practice problem here, and then I will give you the opportunity to do a couple on your own. Okay, so we've got a very complicated looking triangle. Remember we said in class, if the triangles are on top of each other, then it is to your benefit to separate them and be able to look at them. Which triangles do you separate? Well, it depends on what kind of given information that you have. In this case, it tells us that those two angles down in the corners are congruent, and then we got some segments are congruent, and we're going to use those to try to prove that those diagonal segments there are also congruent. So as I look at this, what I see are all the pieces that are given and I'm trying to prove would lead me to separate them into two triangles, triangle BEA and triangle BDC. And watch again how easy this is when you separate your triangles. Now they're not on top of each other. It's much easier to see all of your parts. From the given information, it says that BD is congruent to BE, so I'm going to mark those congruent. And then if I look back up at the big drawing, it says that angle BAC is congruent to BCA. So as soon as I see that, I go, hey, that's an isosceles triangle. The big triangle is. And so I would say that the opposite sides, segment BA is congruent to segment BC. And my reason? Isosceles triangle theorem. And so then I can mark those also on my blue triangles over here to the left, and I can show that BA and BC are indeed congruent. So now I've got two parts down. All I need is one part left. It's not going to be AE, and CD because I'm trying to prove that. So the only other thing it might be is those angle B's. hey, that's the same angle B in each of those triangles. So that is the reflexive property. If you look back at the big black triangle up at the top of the screen, it's the only angle B in the entire picture. So I've got the right three parts to these triangles, so I can say that triangle BEA is congruent to triangle BDC, and that reason is side angle side. The angle is the included angle. Now remember, like we learned yesterday, or a couple days ago, excuse me, when the triangles are congruent, all of their corresponding parts are congruent. And so that means that segment AE is congruent to segment CD by CPCTC. So that is a typical proof that you might have in this section. So now that you've seen one, hopefully you got a chance to write that down. If you got to push pause right now, you can go ahead and pause that so you can get all that written down. But as you're ready now, we look at our proofs. And feel free to pause it now. Alright, hopefully you got an opportunity to work with a partner on these two proofs. They're not easy proofs, but they are proofs that you might see on a quiz or a test. Here are the answers. Again, feel free to pause it now and look through what I've done. Alright, and the very last thing we're going to do, I'm going to show you one more practice problem now. And in this last practice problem, it's going to be a little bit different. In fact, I don't think you see these in the homework tonight, so it might be a good problem to make sure that you copy down right now and know how to do a problem like this. I've drawn a triangle PQR, and I'm going to tell you the lengths of those sides. And I'm going to tell you that this is an isosceles triangle. The only tricky part is I'm not telling you which sides are congruent. So all I'm telling you is that the perimeter of this triangle is somewhere between 40 and 45 units. Your job is to figure out which angle has to be the vertex angle. Now that's not an easy question. You can't just assume the vertex angle is up at the top. So what you're going to have to do is you're going to do a little guess and check right now and figure out what could be your isosceles sides. So I'm just going to guess the two obvious ones. I'm going to say x plus 8 and 2x plus 5 are my congruent sides. So I set them equal to each other. I solve for x. I take my x and I plug it back in. And when I plug it back in, that side over there is going to be 11. When I plug it back in for the other side, that obviously has to be 11 also. This is a good check to make sure I'm doing it right. And then I plug in the bottom, and the bottom down there is only going to be 7. So I take those three sides and add them together, 11, 11, and 7, and I get 29 units. That is not in the range that I was given. So I'm a loser right now. Or I just chose poorly. Or I'm a loser, whatever you prefer to think. So I'm going to try this again. So now I'm going to use x plus 8 and the 3x minus 2. Maybe those are my equal sides. So I subtract x over there, add 2 to the other side, divide by 2, and now I get x equals 5. Now plugging it back in, I get 13 for that side on the left. I get 15 for the side over on the right. Remember, those aren't equal anymore. I've chose the bottom side to be equal to the one on the left. And then when I plug in the bottom, I am going to get 13 there. Again, I'm checking it to make sure that's correct. And so I'm going to take my three sides here, 13 and 13 and 18, add them all together. So 13 and 13 is 26, and 18 is 44. And 44 does happen to be in the range, so I got the correct answer. So here's the last part now. If those are my two congruent sides right there, I mark those two sides congruent, the vertex angle, the one that is not congruent to the other two, must be angle P. And that is the answer to my problem. So you might want to make sure that you understand how to do this problem, because you very well could see it again. Your homework assignment for tonight is on page 267. I'd like you to do problems 7 through 37 odd. Please do those problems now, and we'll talk to you next time.